Hello, good evening, dear students. So, how are you all? After very long time, we all are meeting, right? So, how your classes are going on? So, did you go through the chapters which we have gone through? Yes. Are you revising those? Yes. Okay. So as you know, okay, so May last week we have ended up to amines, right? So amine chapter, so we have left with two more chapters. So amine is half completed, and another chapter is biomolecules. Okay, so this chapter, so after like every day, this time 6 to 7:30. Okay, I'll be taking class. Okay, so until you these two chapters get over. Okay. So any difficulty are you facing in the chat? Any difficulties? No. Okay, fine. Good. Okay. So what we were discussing about amines. Okay. So what are these amines? Yes. So amines are the derivatives of ammonia. Okay. What is ammonia? It is NH3. So just we'll do a quick revision. Okay. I'll not start from again from starting. So just a revision. So ammonia is NH3. So when you replace these hydrogen, okay, by a alkyl group or a aryl group, then you get amines. Okay, you get a derivatives of ammonia are called as amines. Okay, so the replacement of this hydrogen atom, okay, when you replace this hydrogen atom, when you replace one hydrogen atom, you'll get a primary amine. When you replace two hydrogen atoms, you get a secondary amine. When you replace three hydrogen atom, you get a tertiary amine. So this is the thing which we have discussed about the amines. Okay, so what are amines? Amines are the derivatives of ammonia. So how they are represented? RNH2. Okay, RNH2. So this is the okay. So RNH2 is nothing but your we represent our amines. Okay, the representation of amines is RNH2. Okay, fine. So based upon this, we have discussed about the what about the properties also, right? So what all things we have discussed, I'll just tell you. So we have discussed the classification of amines. So depending upon how many hydrogen atoms are replaced, they are called as primary amines. So if one hydrogen atom is replaced primary amine, if two hydrogen atom, if it is replaced by alkyl or aryl group, then it is called as secondary amine. If three, then it is called as the tertiary amines, right? Then we are discussed about the nomenclature, how to name these compounds, okay, how to name this amine compound. So these also we have discussed, right? Then we had discussed the structure of amines. Okay, so the students who have not attended the session of amines, you can go through the videos. Okay, they are available on the YouTube. Okay, so there you can go through these videos again. You can okay, you can recap these all things of amines. Then we had started with the preparation of amines. So how we can prepare amines from different method, right? So six methods of preparation we have discussed. First one was by reduction of nitro compounds, then by reduction of nitriles. Okay, then we had discussed about the reduction of amides, okay, by reduction of amides. Then we have discussed about the Hoffman degraded reaction. Okay, Hoffman bromide degradation reaction. So very important, I have told you. Then we have discussed about the ammonolysis of alkyl halide, right? Then we have discussed about the Gabriel thalamide synthesis. So this is also one of the very important name synthesis, that is Gabriel thalamide synthesis. Okay. So these are the different preparations of amines which we have discussed. Then we have discussed about the physical properties. Okay, how are the physical properties of amines? So that also we have discussed. Okay, then we had discussed about what? Then we had started about the chemical properties. So chemical properties, we have studied the okay, different basic characters of amine. Okay, then so these all things. So next we are going to see the chemical properties, that is the chemical reactions. Okay, so different chemical reactions, how the amines undergo different chemical reactions. Okay, so let us start now. So here. Okay, so the first one is alkylation. Okay, first one is what? Alkylation. So what we do here, so we have a amine. Okay, we know how do we represent amine? We represent as RNH2. Okay, we represent as RNH2. So this is what? This is a primary amine. Why? Because your one of the hydrogen is replaced by what? It is replaced by a alkyl group. Okay, R can be your alkyl group or it can be a aryl group. Okay, so here our amines. So what we are doing in alkylation? So amines will react with the alkyl halide. So how do we represent alkyl halide, students? This we have discussed in haloalkanes, haloarenes, right? How do we represent alkyl halide? Alkyl halide is represented by what? It is represented by Rx. Okay, it is represented by Rx. So what we are going to do? We are going to take primary amine. We are going to react it with. Okay, excess means what? Excess means in more amount. Okay, excess means we are going to take the alkyl halide in more amount. Okay, so this we are going to take. Now what is happening here? So here at each step, what is going to happen is your hydrogen atom will be replaced by the R group. Okay, your hydrogen atom, these hydrogen atoms are there, no? So these hydrogen atoms will be replaced by this R group, that is alkyl group of the alkyl halide. So what will happen? So it will become R2NH. So what we are going to get now? We got a secondary amine, right? We got a secondary amine. Now again, next step, again we are going to react it with alkyl halide. Excess means what? At each step, your alkyl halide is going to react. So what we are doing here, whatever the hydrogen atom is there, okay, that is going to replace by a alkyl or that aryl group, R group. Okay. So what is going to happen now here? You're going to get R3N. So your this hydrogen is replaced by the R group. Okay, so I get what? I get a tertiary amine. So here, what is our byproduct? So your hydrogen is left and your X is left. So minus HX. Again, here also minus HX. Okay, because there is a replacement undergoing. So your hydrogen is replaced by R. So what will happen? What you will be left with? You will be left with HX. Okay, so I'm going to get a tertiary amine. So again, I am going to react it with alkyl halide. Now what I am going to get? I am going to get a quaternary ammonium salt. What I am going to get? I am going to get a quaternary ammonium. Okay, quaternary ammonium salt. Okay, so this is our alkylation reaction. So what we are going to do? We are going to take amines. We are going to react it with excess of alkyl halides. So at each step, what is happening? One of the hydrogen atom is replaced by the your alkyl group. Okay. At each step of the NH2 group, the hydrogen atom is replaced by the alkyl groups and it forms respectively secondary, tertiary, and quaternary ammonium salt. Okay, so this is the final. After this, it cannot form any product. So this is the final product, that is quaternary ammonium salt. So this is alkylation reaction. Okay, this is alkylation reaction. Is it clear? Is it clear what we are doing in alkylation reaction? We are taking primary amine. We are going to react with it excess of alkyl halide. So what is happening at each step? Whatever the hydrogen atom is present of the amine group is replaced by a alkyl group. Okay, and it forms respectively secondary, tertiary and quaternary ammonium salt. Is it clear? Yes? Okay. So this was about alkylation. Okay. So this was about alkylation. Next we are going to see is acylation. Okay. What we will do in acylation? Yes, in acylation, we are going to react it with acetyl chloride. Okay, we are going to react it with acetyl chloride. So let it take a primary or secondary amine and secondary amines. Okay, and these primary and secondary amines, they are reacted with acid chlorides. Okay, they are reacted with what? Acid chlorides. Okay, or they are reacted with acid chlorides, or you can take anhydrides. Okay, or you can take anhydrides, or you can take esters. Okay, or you can take esters. So whatever the hydrogen atom is there of the NH2 group. Okay, so primary group is what? RNH2. So whatever the hydrogen atom is there of this NH2 group, it is replaced by what? It is replaced by, okay, it is replaced by acetyl group. Okay, so this is our acetyl group and it forms N substituted amides. What you get? N substituted amides. And this reaction is called as what? This reaction as acylation reaction. Okay, this reaction is called as what? Acylation reaction. So let me give you, so I will take ethylamine. Okay, let me take a ethylamine. So let me take it like this. So this is our primary amine, ethylamine. Ethylamine, I'm going to react it with acetyl chloride. So this is our acetyl chloride, CH3, CH2, CO, Cl. Okay, so acetyl chloride. And this is what? This is ethylamine. Okay, this is our ethylamine. So what is going to happen? So the lone pairs present on the nitrogen will attack this carbonyl carbon. Okay, so this reaction takes place in the presence of a base like pyridine. So what we are going to get? So C2H5, okay, NH, then here, one of this hydrogen atom will be replaced by your C double bond O CH3 plus HCl. Okay, this H and this Cl will combine to give you HCl. So what we got? We got a N-ethyl ethanamide. Okay, N-ethyl ethanamide. So this is our reaction. Okay, this is our reaction. So what we are doing? We are doing acylation. Okay, in acylation, we are going to take what? Acetyl chloride. What we are going to take? Acetyl chloride. Okay, so what we have done here? We have taken ethylamine. We are reacted with acetyl chloride. So what is happening here? The hydrogen atom, okay, of the amine is replaced by what? It is replaced by the acetyl group. Okay, CH3CO group, this group. So your hydrogen atom is replaced by this group and you get HCl. So this H and this Cl will combine to give you HCl. Is it clear? Okay, so this is, now I have taken primary. Okay, I have taken first one as a primary. Now let me take second one as secondary. Okay, let us take a secondary amine and let us see the reaction now. Acylation reaction, how it will go. Okay, so second reaction. So let me take diethylamine. What is diethylamine now? CH2N and C2H5 and H. Okay, so so this is C2H5N H plus acetyl chloride. So CHC, C double bond O, Cl. So the lone pair of electrons on the nitrogen will attack this carbonyl carbon. And what I'm going to get? I'm going to get what? Just see. So in this reaction will go under the presence of pyridine. Yes, I'm going to get C2H5 N C2H5. So our hydrogen will be replaced with what? I'll going to get C double bond O CH3 plus HCl. So what is the product? The name is N N N N diethyl N N diethyl ethanamide. Okay, diethyl ethanamide. So this is the reaction. Is it clear? Ethanamide. Okay, ethanamide. I'll write the spelling properly. Diethyl ethanamide. Okay. Is it clear up to here? So I've taken one primary and this is secondary. Yes, okay. So let us take now. Uh, Now this was alkyl amines, right? Now we will take a aryl amines. Let us take a aryl amines now. Okay, aryl amines means what? A benzene ring. So which is the simplest aryl amine, students? Which is the simplest aryl amine? Aniline. Okay, let us take aniline. Let us take aniline. Let us take aniline. Okay. So this is our aniline, NH2, primary aromatic amine. Okay. So now, which were the, so we can react it with acetyl chloride. Okay. Or we can react it with anhydrides. Okay. Or we can react it with what? Esters. So now we will take anhydrides. Okay. We will take anhydride. So let me take acetic anhydride. Okay. Let me take a acetic anhydride. So this is our acetic anhydride. So this is what? This is aniline. Okay, and this is our acetic anhydride. Acetic anhydride. Okay. So tell me what will be the product, students? Can anyone tell me what will be the product? Yes. What is the product? Yes. Okay. So I'll tell you the product. N-phenyl ethanamide. Okay. Baby has answered as N-phenyl ethanamide. Yes, very good. It is correct. Okay. Or it is acetanilide. Yes, very good. Shivaruni has also answered it. Very good. Okay. So let us write the product. So let us write the product. So it is what? So your, this is your benzene ring. So one of the hydrogen. Now your two hydrogens are there, right? So one of the hydrogen will be replaced by your one acetyl group. Okay, so this group will be replaced. So now here what I am going to get? N, okay, N, H, NH, then C double bond O, CH3 plus whatever this is this. Okay, so what I'm going to get? CH3, C double bond O, OH. Okay, CH3, C double bond O, OH. Is it clear? So the name is what? The name is acetanilide. So it is acetanilide or or N-phenyl ethanamide, ethanamide. Okay. And this is what? This is acetic acid. This is acetic acid. Okay. Is it clear? So this is with our primary aromatic amine, we are reacting with the acetamide. Okay. So what will happen? So your NH will come, one of this hydrogen atom will be replaced by this. And what will happen? Your CH3, C double bond O will get attached with the hydrogen and you're going to get the byproduct. Okay, fine. Let us see next reaction. So here, so what we have seen that only primary and secondary amines, okay? So we know that only primary and secondary amines, they will undergo this acylation reaction. Okay, so we have seen that only primary and secondary amines will undergo acylation reaction. Okay, tertiary will not undergo. Why? What will be the reason why tertiary amines will not undergo this acylation reaction? Any particular reason, students? So this is our primary. This is our, okay, so I'll write the structure. Then you will come to know. Okay, so this is our tertiary, primary, and this is secondary. Okay, somebody has answered. They are unstable. No, a better answer. Anybody? Yes, try. So you can see the structure now. Okay, I've drawn the structure here. This is primary, secondary, and tertiary. See the structure and you'll come to know because there are no hydrogens. Yes, very good. So in the tertiary structure, okay, in this tertiary, okay, in the tertiary primary, that is your tertiary amine, you can see there is no replaceable hydrogens. So, okay, there is no replaceable hydrogen. In primary and secondary, we have replaceable hydrogens, right? Here we have one, here we have two. In tertiary, we do not have any replaceable hydrogen atom which is bonded to the nitrogen, right? So this is the reason, okay? So primary and secondary will undergo acylation reaction and tertiary will not undergo. So remember this, okay? Okay. Fine. So next, so we have seen alkylation. Okay. Next, we have seen what? Acylation. Now, next, let us see the name reaction, that is carbylamine reaction. Okay. Next is what? Carbylamine reaction. Very important. Mark this as important, students. 2-mark question. Okay. So mark this as important. Carbylamine reaction. Very important for 2 marks. Okay, fine. So what is happening in this carbylamide reaction? Okay, so we have a primary, we have what? We have secondary amines. We have what? We have a primary amines. We have what? We have our primary amines. Okay, let us take a primary amine. So primary amine, okay, how we are going to represent primary amine? RNH2. Okay, RNH2. So this primary amine, we are going to react it with a mixture. Okay, with a mixture of what? With a mixture of your chloroform. Chloroform is what? CHCl3. Okay, with a mixture of CHCl3 and what? Chloroform, mixture of chloroform and alcoholic KOH. Okay, alcoholic KOH, that is potassium hydroxide. So let me write alcoholic KOH. Okay, so this is alcoholic. So primary amine is there. We are going to react it with what? Chloroform and alcoholic KOH, and we are going to heat this. We are going to heat this. So primary amines, we are going to take a mixture of chloroform and alcoholic KOH, and we are going to heat this mixture. And what we are going to get? We are going to get isocyanides. Okay, we are going to get what? Isocyanides. So what is isocyanide? RNC. Right, we know this now. What is isocyanide? What is cyanides? Cyanides is RCN. Okay, RCN is cyanide or we called as nitriles. Right, RNC. Okay, so RNC is what? Isocyanates. Fine. Remember this. So we are going to get what? We are going to get the isocyanates. Okay, we are going to get isocyanates plus the byproducts 3KCl plus 3H2. Remember this. Okay. So this is the carbylamine reaction. So we are going to get, they are called as carbylamines or we called it as isocyanates. Okay, and these are having very bad smell. Okay, or we call it as fall smells. Okay, we get a fall smell. Okay, so let us see now one example. Let us see one example. So which amine I'll take? I'll take a simplest amine, that is methylamine. Okay, I'll get a methylamine. Again, I'm going to take a mixture of chloroform plus alcoholic KOH. Okay, I'm going to take alcoholic KOH and I'm going to heat it. Can you tell me what will be the product, students? Yes, yes, can you tell me the product? Try. Okay, trying is not a big thing, so please try. Okay, I'll tell you then. So it will be CH3 and C. Okay, CH3 and C. We are going to get methyl isocyanide. Yes, methyl CHCNC. Yes, very good. Shivaruni has answered. So it is methyl isocyanide. Okay, we are going to get methyl isocyanide plus and see, remember Yes. Can you see the screen now? Okay, fine. So let us continue. Fine. Okay, so we were discussing about the carbalamines. Okay, we are discussing about carbalamines, carbalamine reaction. So we have seen first with our what methylamine. So let us see with aniline. So aniline is there. Okay, aniline is there. This aniline, we are going to react it with what? We are going to heat it with a mixture of chloroform plus your ethanoic, that is your alcoholic KOH, okay, potassium hydroxide. Okay, so this is alcoholic and we are going to heat this mixture and what we are going to get? I'm going to get a phenyl isocyanide. Okay, I'm going to get a phenyl isocyanide plus 3KCl plus 3H2O. Okay, so this is the reaction. Is it clear? Carbalamine reaction is it clear? So remember that only primary amines, okay, only primary amines will undergo this carbalamine reaction. Okay, remember this, only primary amines, okay, only primary amines will undergo what? It will undergo the carbalamine reaction. Okay, fine. Is it clear, carbalamine reactions? Okay, fine. Now let us go for the next one. Next one is, so we have seen alkylation, acylation, then carbalamine reaction. Now we are going to see reaction with nitrous acid. Okay, reaction with nitrous acid. What is nitrous acid? How we get nitrous acid? Yes, how we get nitrous acid? So A, B, C, D. Okay. So nitrous acid. Okay. So we have aliphatic primary amines. So let us take aliphatic primary amines. Aliphatic primary amines means what? Aliphatic primary amines means what? Okay, when you have the carbon atoms, okay, in a chain or in a branch form like that. So they are aliphatic, right? Aromatic means when you have the R group as a aryl group. So we take a aliphatic primary amine. So we need what? We need a aliphatic primary amine. So this aliphatic primary amine, so your R should be your methyl group or it should be a ethyl group. So this I'm going to react it with nitrous acid. So how I am going to get this nitrous acid? So when you take a sodium nitrate, okay, when you take NaNa2 and when you react it with HCl, okay, when you take NaNO2, that is sodium nitrate. So let me write the name. So this is sodium nitrite. Okay, this is sodium nitrite. And I'm going to react it with what? Hydrochloric acid. I'm going to react it with what? Hydrochloric acid. What I'm going to get? I'm going to get this nitrous acid, HNO2. From this, we are going to generate this. Okay, from this, we are going to generate what? Our nitrous acid. NaNO2 plus HCl will give you nitrous acid. Then, when this, what is this? Primary amine, when it reacts with nitrous acid, I am going to get, okay, I am going to get a diazonium salt. Okay, I am going to get what? Diazonium salt. Okay, diazonium salt. Okay, I'm going to get diazonium salt. This diazonium salt is unstable. Okay, this is unstable. This, when you do hydrolysis, okay, when you treat it with water, I'm going to get alcohols. Okay, I'm going to get alcohol plus N2 gas will be liberated. Okay, N2 gas will be liberated plus you get HCl. Is it clear up to here? So this is the reaction with nitrous acid. Okay, this is the reaction with nitrous acid. So what we did, we took a primary amine. Okay, we took a primary amine. Then we reacted with nitrous acid. How we get nitrous acid? When NaNO2, that is sodium nitrite, when it reacts it with your hydrochloric acid, you get what? You get diazonium salt. This diazonium salt is what? It is unstable. Okay, they are unstable and they will decompose. Okay, they will easily decompose to give you alcohol with loss of N2 gas. Okay, nitrogen gas is liberated and HCl gas is also liberated. So this is with aliphatic amine. Then this this reaction can undergo with aromatic amines also. Okay, this reaction can be it can undergo with uh, what? Aromatic amines also. So let us take aromatic amine. Which amine I'll take? I'll take a aniline. I'll take aniline. Okay. Aniline, I'm going to treat it with what? NaNO2 plus HCl. So when NaNO2 plus HCl reacts, okay, what I'm going to get? I'm going to get what? I'm going to get the nitrous acid. That is HNO2 is generated. So there is a condition. Okay, there is one condition, that is it should be at 0 to 5 degrees Celsius or 273 to 278 Kelvin. So this is a reaction condition. So when aniline, okay, very important, mark this as important. So when aniline reacts with the nitrous acid, that is HNO2, at a low temperature. So this is a very low temperature, right? So this is a very low temperature at 0 to 5 degrees Celsius. What we are going to get? We are going to get a diazonium salt. We are going to get what? N2 plus and Cl minus. Okay, we are going to get what? What is the name then? It is a benzene diazonium chloride. Okay, benzene diazonium chloride. This benzene diazonium chloride plus we are going to get NaCl plus we are going to get H2O. So this reaction is called as diazotization reaction. What it is called as? Diazotization reaction. Okay, what it is called as? Diazotization reaction. Is it clear? Okay, so when aniline, so how we get nitrous acid? Remember that when NaNO2, that is your sodium nitrite, reacts with HCl, we are going to get nitrous acid. So when aniline reacts with your nitrous acid, so a condition is that the temperature condition should be very low. That is, it should maintain a temperature of 0 to 5 degrees Celsius or at Kelvin, it is represented as 273 to 278 Kelvin. What we are going to get? We are going to get benzene diazonium chloride. What we are going to get? Benzene diazonium chloride and it's NaCl plus 2H2O. This name reaction is called as diazotization reaction. So please, you can note down this, very important. So aromatic primary amines, when it reacts with nitrous acid at a lower temperature of 0 to 5 degrees Celsius to form diazonium salts, this reaction is called as diazotization reaction. So very important from CET point of view, that is from competitive point of view. Okay, so diazotization reactions are very important from this amine. So separately, after finishing the chemical reaction, we are going to study about diazotization. Okay, diazotization reaction separately. Okay, we have a after this we are going to study about diazotization reaction. Okay, is it clear? So secondary and tertiary amines also react with nitrous acid, but they react differently. Okay, they are going to react differently. So, but you have for your syllabus primary amines. So please go through this primary. Okay, so is it clear? Is it clear about the diazotization reactions? Any doubts up to here? Yes, if you have any doubts, you can ask me at any point. Okay. Okay. So let us go for the next one. Next is reaction with aryl sulfonyl chloride. Okay, next is, these are all chemical reaction. Okay, how our amines are going to react it with different. So this is the aryl sulfonyl chloride. So this is a test to distinguish. Okay, this is a test to distinguish. Distinguish means what? To differentiate. Okay, to differentiate between primary, secondary, and tertiary amines. So this is a test to differentiate between the primary, secondary, and tertiary amine. So which aryl sulfonyl chloride we are going to get? We are going to take the benzyl sulfonyl chloride. We are going to take what? We are going to take a benzene sulfonyl chloride. Okay. So what is the structure? It is C6H5SO2Cl. Okay. So this is known as Hinsberg reagent. Very important. Mark this important. There can be a question, 1 mark question. What is Hinsberg reagent? For competitive also, for your boards also. What is Hinsberg reagent? So benzyl sulfonyl chloride. Okay, the formula is C6H5SO2Cl. SO2Cl. So what I'm going to get? So benzyl sulfonyl chloride. Okay, it is, that is C6H5SO2Cl. Okay, so this is your Hinsberg reagent. So we are going to do what? We are going to differentiate. So this is a test to differentiate between a primary, secondary, and tertiary amines. Okay, so let us see how the primary and primary amines react. So let us take a primary amines first. Okay, let us take a primary amine. So let us take what? We will take sulfonyl chloride. So sulfonyl chloride is C6H5. Okay, SO2Cl. So this is our benzyl sulfonyl chloride. And we are going to take a amine. So let us take ethylamine. Okay, ethylamine. So I have just changed the position. So this is what? This is our ethylamine. Okay, this is our ethylamine. So what we are going to do now? This, we are going to react it in the presence of a base like pyridine. Okay, so what we are going to get? Our one of the hydrogen will be replaced by the sulfonyl group. So what we are going to get? We are going to get the benzene ring. Okay, S double bond O, double bond O. So one of the hydrogen is replaced by what? It is replaced by your the whole group. Okay, so I'm going to get the byproduct as HCl. So what I got? The product is N-ethyl, then benzene, N-ethyl benzyl sulfonamide. Okay, N-ethyl benzyl sulfonamide. So this is soluble in alkali. This is okay. This is soluble in alkali. So with primary amines, what happens? The hydrogen atom, okay, which is attached to the nitrogen. So here the hydrogen atom which is there, okay, which is attached to the nitrogen, it is strongly, okay, it is strongly, what you say, acidic. Why? Due to the presence of the withdrawing group, that is sulfonyl group. So because of this, so here what you can see, the hydrogen group. So this is a hydrogen atom which is attached to the nitrogen. Okay, in this okay, in this sulfonamide, you can see this hydrogen which is attached to the nitrogen of the sulfonamide. It is strong. It is strongly acidic. Why? There is a presence of this electron withdrawing sulfonyl group. So this is an electron withdrawing group, right? So because of this, this is soluble in alkali. So when the product is soluble in alkali, then it tells you that it is a primary amine. Okay, it is a primary amine. So let us see with secondary amines. So let us see with secondary amines now. So again, I have a benzene sulfonyl chloride. So S double bond O, S double bond O, Cl plus ethylamine. So we are going to take a diethylamine. So N C2H5 and H, right? So what is going to happen now in the presence of pyridine? In the presence of pyridine. So let me take another color. Okay. So here, what is happening? So your hydrogen will be replaced by this group, complete group. So what I'm going to get? I'm going to get this S double bond O, S double bond O, N, okay, C2H5 and C2H5, okay, plus HCl, plus HCl. What I got? I got N and diethyl, N and diethyl benzene sulfonamide. Okay, benzene sulfonamide. Okay, so this is insoluble in alkali. This is insoluble in alkali. What is the reason? Can anybody tell me what is the reason? This was soluble in alkali. Okay, this product was soluble in alkali. When it was soluble in alkali, we said it is a primary amine. Okay, now here it is not soluble in alkali. Why it is not soluble in alkali, students? Can anyone tell me why it is not soluble in alkali? Why it is insoluble? Yes, please try. Why it is insoluble? You can see at the structures. Okay, in ethylamine, that is your primary amine, and this is a diethylamine, that is your secondary amines. Okay, so what is the difference? What is the difference? What we said here, there was a acidic hydrogen. Okay, there was a hydrogen atom which is attached to the nitrogen of the sulfonamide. It is strongly acidic. What is the reason? Because there is a presence of this strong electron withdrawing sulfonyl group. Okay, because of this presence of the sulfonyl group, okay, what happens? It is soluble in alkali. Now, why it is insoluble in alkali? The secondary amines, why they are insoluble in alkali? What you can see? Can you see here any hydrogen atom? Yes. Can you see any extra hydrogen atom attached to the nitrogen atom? No. Right. So, as in the case of N,N-diethyl benzyl sulfonamide, it does not contain what? It does not contain any acidic hydrogen. Okay, it does not contain any acidic hydrogen atom which is attached to the nitrogen. Because of this, it is insoluble in alkali. Okay, it is insoluble in alkali. Is it clear? Is it clear now? So, what you can see in secondary amines, there is no acidic hydrogen atom present, okay, or it is attached to the nitrogen. And because of this, it is insoluble in alkali. Is it clear? Is it clear? So primary amine, when it reacts with benzyl sulfonyl chloride, it is soluble in alkali. Secondary amines, when it reacts with benzyl sulfonyl chloride, it is insoluble in alkali. What is the reason? It does not contain any acidic hydrogen atom attached to the nitrogen. Because of that, it is insoluble in alkali. Can you tell me about tertiary amines now? Tertiary amines, what will be the reaction with tertiary amines, students? Tertiary amines. How can you distinguish between tertiary amines? So if we take a tertiary amine, okay. So what will be the reaction? It will, you cannot say insoluble. It does not react. Okay, it does not react. Why? Because there is no hydrogen atom itself. Okay, so tertiary amines, what you have to write then? You have to write tertiary amine does not react. What you have to write? Tertiary amine does not react with benzene sulfonyl chloride. It does not react with benzene sulfonyl chloride because there are no replaceable hydrogen atom. Okay, there is no replaceable hydrogen atom. Is it clear? Okay, so this is the distinguishing test between primary, secondary, and tertiary amine. So please note it down, very important. Okay, so primary amines, when it reacts with the benzene sulfonyl chloride, you get N-ethyl benzyl sulfonamide Okay, so here you can see the hydrogen atom which is attached to the nitrogen in the sulfonamide. It is acidic in nature. Okay, why? Because there is a presence of strong withdrawing group, that is your sulfonyl group. Because of that, it is soluble in soluble. Okay, then in second case, that is your secondary amines. There is no hydrogen atom. There is no acidic hydrogen atom present. So because of this reason, okay, it is insoluble in alkali. Then tertiary amines. Tertiary amine, they do not react with benzyl sulfonyl chloride because there are no replaceable hydrogen atoms. Okay, is it clear? So, so these was a reaction forms.
Yes, ma'am.
Okay, so this was in reaction forms. So if you want, you can write like this also, primary amine. Okay, and then you can write secondary amine and you can write tertiary amine. So what is the test? Test is that reaction with benzene sulfonyl chloride. What is benzene sulfonyl chloride called as? Hinsberg reagent. Remember this, okay? Hinsberg reagent. What it forms with primary amine? It forms sulfonamides. Okay, it forms sulfonamides. Okay, which are soluble in alkali. Okay, which are soluble in alkali. Then secondary amines, they form sulfonamides. These also fall sulfonamides. Okay, but these are which are insoluble in alkali. So these are insoluble in alkali. So both produce the sulfonamides, but this is soluble in alkali, this is insoluble. What is the reason? There is acidic hydrogen atom present. Okay, and there is no acidic hydrogen atom present. Okay, so remember that. And in tertiary amines, they do not react. So no reaction is possible because there is no hydrogen atom itself. Is it clear? Okay. So this was about the Hinsberg reagent. Okay, this was about the Hinsberg reagent. Next, we are going to see the electrophilic substitution reaction. Next is what? Electrophilic substitution, electrophilic substitution reaction. Okay. So here, what happens in electrophilic substitution reactions? We have amines, right? Now, suppose we have amines. So here, the NH2 group, okay, here the NH2 group, it is a activating group. Okay, it activates the benzene ring. It activates the benzene ring for the electrophilic substitution reaction. Okay, and whatever the incoming electrophile is there, it will attack at ortho and para position. Okay, so at ortho and para, the substitution takes place. So let us see first one, bromination. First one is what? Bromination. So we are going to take aniline. So let us take aniline. So aniline, how we are going to take bromination? We are going to react it with 3Br2 in the presence of bromine water. Okay, so aniline, it reacts with bromine water at room temperature. Okay, at room temperature, and it gives you a white PPT. It gives you a white PPT of what? It gives you a white PPT of 2, 4. So 2, and this is 4 position, and this is 6 position. So 2, 4, 6 tri bromo aniline. Okay, so this is the reaction at room temperature. Okay, so when aniline reacts with bromine water at room temperature, you get a white PPT. Okay, this white PPT is of what? 2,4,6 tribromoaniline. Okay, so this is your bromination reaction. Okay, this is your bromination reaction. Next is your, we will do what? acylation. Okay, next is our acylation reaction. Next is acylation. Acylation means what? In the presence of acetyl chloride. So let us take a aniline. Okay, aniline in the presence of what? In the presence of C double bond O, that is your acetic anhydride. So we have taken acetic anhydride in the presence of pyridine. Okay, in the presence of base like pyridine, what I'm going to get? I'm going to get a acetanilide. Okay, we are going to get what? NH C double bond O CH3. Okay, this I'm going to get what? Acetanilide or N-phenyl ethanamide. Okay, acetanilide, or I call it as N-phenyl ethanamide. This on further reacting with bromine in acetic acid. Okay, if you react first, we'll do acetylation, then we will do halogenation. What we are going to get? We are going to get a para and bromo substituted acetanilide. Okay, we are going to get NH, C double bond O CH3 and Br, plus we are going to get NH, C double bond O CH3 and Br. Okay, so we are going to get what? We are going to get mono substituted. No, we are going to get mono substituted this. Okay, we are going to get the mono substituted acetanilide. Okay, this further I'm going to do hydrolysis. Okay, I'm going to do hydrolysis. What will happen? Your acetanilide group. Okay, our acetanilide group will be converted to NH2 and Br. So we get 4-bromoaniline. Okay, 4-bromoaniline. So this is another method to get a para substituted product. So first what we are going to do? We are going to take aniline. Okay, we are going to take aniline. We are going to do acetylation. First we are going to do acetylation with acetic anhydride. So this is acetic anhydride. Okay, acetic anhydride in the presence of pyridine. We are going to get a acetanilide. This on further halogenation. So this is a halogenating agent. We are going to get a para-bromo acetanilide. Okay, a para-bromo acetanilide. This on further hydrolysis, we are going to get NH2 group. So this group is changed by NH2. Okay, so we get 4-bromoaniline. So whenever you want a monosubstituted derivative, okay, on aniline, first we are going to do acetylation followed by halogenation. Okay, so this is the your halogenation. So both are halogenation only. Okay, when we do bromination at room temperature, we get what? We get a tri-substituted product. We get a tri-substituted product. If we want a mono-substituted product, okay, when we want a mono-substituted product, first we are going to get what? We are going to do acetylation followed by halogenation. Okay, is it clear? So this is first one is bromination. Okay, so with at room temperature, we get a tri-substituted product, and when we react it with a when we react it with a that is when we want a mono-substituted product, then what we are going to do? We are going to do acetylation followed by the halogenation. Okay. Next, we are going to see is the nitration. Is it clear up to here? Next is nitration. In nitration, which is our nitrating agent or which is our electrophile? Yes, which is our electrophile. So we take aniline again. We take aniline. Okay. Our nitrating agent is what? HNO3 plus H2SO4. Okay. When so nitration. So again here, when we do a direct nitration on aniline, we are going to get a black tarry product. Okay. So due to oxidation, we are going to get black that is tarry product, and we are going to get at 288 Kelvin, what we are going to get? We are going to get a byproducts like this. Okay, NH2, NO2 plus NH2. So this is ortho, para, and so para, meta, and ortho substituted product we are going to get at one stretch only. So this is 2%, this is 47%, this is 51%. But the product obtained will be a black tarry substance. Okay, you do not get a proper product. Okay, you get a black substance by this reaction. So what we are going to do now? Okay, so alternative method. So we can take again aniline. Okay, we will take aniline. First we will do acetylation. Okay, let us do acetylation. How we are going to do acetylation? Okay, with acetic anhydride in the presence of pyridine. Okay, so what we are going to get? We are going to protect the NH2 group. Okay, we are going to protect the NH2 group. We are going to get acetanilide. Okay, we are going to get acetanilide. Then what we are going to go do? Then we are going to do nitration. Okay, then we are going to do nitration. Okay, that is H2SO4 in the presence of HNO3 at 298 Kelvin. Then we are going to get what? The para substituted product of NH, C double bond OCH3 and NO2. So this is para nitroanilide. Okay, acetanilide. Acetanilide. Okay, so para nitroacetanilide. Further again, what we are going to do? I am going to do hydrolysis. Okay, and I am going to get my NH2 group back. I am going to get NH2 group back. So what I got? I got 4 nitroanilide. Okay, so direct nitration, what is happening? You're not going to get a product. Okay, we are going to get a black tarry product. Tarry means what? You don't get a good product, you get black substance. It converts into a black substance. So direct nitration is not possible because it will undergo oxidation. Why it is forming black color product? Because it is undergoing oxidation. How it will undergo oxidation? Because it can easily react with the oxygen present in the atmosphere, right? When it reacts with the oxygen present in the atmosphere, it will undergo oxidation and it will convert easily into a black product substance. Okay, so because of that, because the NH2 group is highly activating group, so we are going to protect this NH2 group. How? First, by doing acetylation. Okay, by doing acetylation first, we are going to protect it, and then okay, we are going to convert into acetanilide. Then we are going to do nitration. Okay, how we did halogenation? Same way we are going to do nitration. Is it clear? Is it clear? Both halogenation, that is bromination, and nitration. So two electrophilic substitution reactions we have seen. Is it clear up to here? Okay. Next one, sulfonation. Next one is what? Sulfonation. Okay. So what we are going to do in sulfonation, mark this as important for 2 marks. Mark this as important for 2 marks. So sulfonation, take NH2, aniline, okay. React it with what? H2SO4. React it with what? H2SO4. What I'm going to get? I am going to get a NH3SHSO4. Okay, NH3 plus HSO4. So aniline, it reacts with the concentrated H2SO4 to get a anilinium hydrogen sulfate. Okay, this on heating further, okay, you're going to heat it at 453 to 473 Kelvin. Okay, in the presence of your H2SO4, we are going to get sulfonic acid. What we are going to get? We are going to get sulfonic acid. sulfanilic acid. Okay. So this is your sulfonation. So aniline, when you react it with concentrated H2SO4, you get anilinium hydrogen sulfate, which on further heating with H2SO4 at the temperature of 453 to 473 Kelvin, you get sulfanilic acid. Okay. Or you called it as para-amino benzene sulfonic acid. Para-amino benzene sulfonic acid. Okay, you can call any or okay, sulfanilic acid or para-amino benzene sulfonic acid. Okay, so this is the third reaction. So we have seen bromination, nitration, and sulfonation. So aniline does not undergo Friedel-Crafts reaction. Okay, because it will form salt. When it reacts with a Friedel-Crafts reaction, that is when it reacts with alkyl chloride or acetyl chloride in the presence of the Lewis acid. Okay, Lewis, that is your this AlCl3. What it will give you, Lewis, okay, it will result, okay, it will because of the strong because it is a strong activating group. Okay, the nitrogen atom, it gets positive charge. Okay, because it is acting as a stronger deactivating group. So for further substitution it is little difficult. So aniline does not undergo Friedel-Crafts reaction. So these are the three this what your electrophilic substitution reaction. So bromination, nitration, and sulfonation. Is it clear up to here? So this completes our aniline. Okay, this completes our aniline. Then we have what? Then we have a is it clear? Any doubts up to here? So then we have a very small part of diazonium salts. Okay. So diazonium salts. So in that diazonium salts, what all we are going to study about diazonium salt is we are going to study about the nomenclature. Okay. Nomenclature. Then we are going to study the methods of preparation. Then we are going to study the chemical reactions. Okay. Different chemical reactions involved in that. Okay. So that all things we are going to see and what are the importance of the diazonium salt. So let us take this diazonium salt in tomorrow's class. Okay. Any difficulty in today's class? Anything you have any doubts on any particular concept? Yes, so today we have completed about amines. Tomorrow separately we are going to study about diazonium salt. How do we represent diazonium salt? So let me start. So diazonium salt Rn2 plus X minus. Okay. So here these are called as the diazonium salt. So this is the general formula. So this is the general formula. Okay, just introduction. So general formula of diazonium salt. Diazonium salts. Okay. So general formula is R into X, N2 plus X minus. Okay. Now here R is what? R can be your alkyl or aryl group. R can be your alkyl or aryl group. Then N2 plus is what? N2 plus is your diazonium group. N2 plus is your diazonium group. Okay. How it is represented? R plus, okay, and like this. So this is your N2 plus. It is represented like this. And X minus is what? X minus can be your Cl minus, Br minus, okay, HSO4 minus, BF4 minus, etc. So these are your X. So this is about your diazonium salt. Okay. Fine. So the nomenclature and the other things we will discuss in the next class. Anything you want to ask? Any doubts? Yes. Any questions you have? Okay. Fine. So tomorrow, in tomorrow's class, we are going to complete about the amines. Okay. Okay. So after completing amines, then we will see the next chapter, that is biomolecules. Okay. Fine. So tomorrow, one more class I require to complete this particular chapter, amines. So if you have any doubts, Okay, just go through the things, whatever I have told you today. So you can come back tomorrow, and if you find any difficulty, and you can ask me. Okay, fine. So yes, fine. So there are no doubts. Okay. So I shall end the session here. Okay. So we'll meet in tomorrow's class. Thank you.